Welcome back folks to lesson 12 of the Dead Earth game development series brought to you by the Game Institute. I'm Gary Simmons, and in the last lesson we saw how to bring in a load of animations and characters that while bipedal in nature had incompatible rigs, and we saw how we could create humanoid avatars to perform humanoid retargeting so that all of our animations worked on all of our humanoid characters. But we don't want to just see our animations playing in the preview window of the inspector, we want to have our animations happening in the scene. Of course, in a real game, a character is going to have a large list of animation clips that it's going to want to play. A character will typically have an idle animation, a walk animation, maybe a couple of turning animations, some attack animations, a running animation. So we need to let Unity know which animation should be getting played on a character at any given time. One of the most powerful features that was introduced with Mechanim in Unity 4 was the ability for us to build animation controllers. These are essentially project assets that allow us via the editor using Unity's Animator window to build a complex animation state machine from all of our animation clips. This state machine allows us to define parameters that can then be set via our scripts. Furthermore, we can use those parameters to drive the transitions from one animation clip to another. Now we're going to see how to do that in a moment, but before we start, there's just a little bit of project cleanup I want to do. And if you haven't downloaded the zip file that accompanies this lesson, make sure you go and grab that from the website, because there is a package file in there that we're going to need to use for some of my demonstrations called testanimations.package. So first thing I'm going to do is I'm going to delete these three zombies from our scene, okay? That's zombie 1, Jill and Derek, because we don't need those. And I'm also going to delete this agent from the scene. Remember from a few demos ago, that was the cylinder with the NavMesh agent component that we had on it that used to walk around our level. So I'm going to disable that for the time being. I'm not going to delete it though. And I'm also going to go down to the project view. Now, if you've set up your project like I have, there's a folder that I want you to delete because it's going to kind of get in the way of the package of mine that I want to import. So I want you to open up the standard assets folder, open up the characters folder, and open up the third person character folder. Now, there's a folder in there called animation, which contains some of the default animations that Unity provides us with. Now, my test package also includes some of these, and as a result they won't be imported again a second time. The thing is, I want all of those animations to be imported in the Dead Earth folder. So I'm going to delete the animation folder so that these animations, along with some of the new ones in the package, all get imported into the same folder in the Dead Earth folder. So I want you to select the animation folder, click delete, and then what I want you to do is I want you to find that package. Like I said, it's called testanimations.unity package, and I want you to double click it so that it imports into Unity. And when this window comes up, you can see it's going to create a new folder in our Dead Earth animations folder called Unity Technologies, because these are animations that were supplied by Unity Technologies. And we also know that that animations folder is where we keep all of our animations grouped by the company name that we got them from. So if I click import, and then I close up the standard assets folder and open up my Dead Earth folder, if we look in the animations folder, you can see we have our Mixamo animations, our motion capture online animations, and our Unity Technologies animations. Okay, so the next thing I want to do is, I should have done this at the end of the last lesson, but we have all of our models stored in this models folder, and currently we've only put Mixamo characters in there, which is why we only have one subfolder. But we also imported this kind of weird mutant zombie in the last lesson. Where is it? There it is. So this really should be stored in our models folder too. So what I'm going to do, because I want all of my models grouped into folders based on company name, this was given to us by a company called Pixel Tiger, or PXL Tiger. I'm just assuming it was short for Pixel. So let's rename the top level folder that came in with that asset to Pixel Tiger. And let's go and drag and drop that into our models folder, get it out of the way of the root. There you go. Now we are in good shape. So we're going to start really simple. We're going to drag a character into our scene, and we're going to create an animation state machine for it that has a single state, a single animation clip. We'll use an idle clip for that, and we'll just have it loop over and over again so that we see our character just standing there and idling away. So we're going to start by going to our models folder, into our Mixamo characters folder, And I think I'm going to use Zombie Jill for this demonstration. Now when I select Jill in the hierarchy, you'll notice that there's two components on her game object. There's the mandatory transform component, of course, which all game objects have, but there's this animator component, which you may not have seen before. Now the animator is kind of the thing that glues everything together. It takes the current state of the animation clip being played in the animation state machine, which Unity refers to as an animator controller, and it applies those changes to the avatar, and then obviously eventually onto the actual rig itself. Now as you can see, Unity has automatically assigned Jill's avatar, so we don't need to do that, and it's also got a little tick box that says if there's any root motion in this animation, I want you to use this root motion to actually update the transform of this game object. Obviously if there is no root motion in the animation clip, that won't happen, and also if we untick this box it won't happen too. But if I press play at the moment, nothing's going to happen, and that's because we have not assigned an animator controller to the controller slot. So therefore, this animator has no idea what animation clip should be getting played. That's the whole point of the controller. So we're going to have to create a simple animator controller with just one animation clip in it. Also, later on when we write some scripts, you're going to see how the animator component exposes a rich set of functions that allow us to really control the state of the animation state machine, and also set and fetch parameters, as well as do some really cool other stuff to the character, such as making the head of the character look in a certain direction, such as match targeting so that we can have a character jump up onto a ledge and make sure that the hands meet the edge of that ledge at exactly the right point in time. But for now, let's just create that controller. So I'm going to go to my Dead Earth folder. I'm going to right click and create a new folder in there called Animator Controllers. If throughout this video and other videos I refer to it as an animation controller, then this is what I mean. An animator controller just doesn't seem right to me, but that's what Unity calls them. So I'm going to drill down into that folder and I'm going to right click. I'm going to choose create and I'm going to create a new animator controller asset. And I'm going to call this My Test Controller. And you can see that the animator controller has its own little icon in the Unity project window, so it stands out a mile in a big list of other assets, and we need to assign this controller to our Jill character, and we do that via the controller property on its animator. So let's drag and drop that in there. Now at the moment that controller is totally empty, so we're going to open up that animator controller we just created and we're going to add our first state to it, and that's going to be an idle animation clip. So there's several ways that we can open up an animator controller for editing. One way is we can simply just double click on it in the project view, and this will open up Unity's animator window, which is our means of constructing our animation clip state machine. However, sometimes it's more useful to do it another way. So if I close down the animator window and I select Jill in the hierarchy so that she's currently selected, I can then go to the window menu and choose animator, and that will open up whatever animator controller is assigned to the animator component of the object that you've got selected in the hierarchy. Now just be mindful when you use the window menu to open up the animator window, there's the animator option, which is the one we want to use, and there's the animation option as well. This opens up an entirely different window which we can use to author our own animation clips from within inside Unity. So it's the animator window that you want. Now this is currently an empty state machine. Don't worry about these entry and exit nodes and this any state node. We'll be talking about those much later when we do some more complex things with the state machine. Notice on the left hand side of the animator window there we have a layers tab and a parameters tab. Now the parameters tab currently says list is empty, and that's because we have defined no parameters for this animator controller. But don't worry, we're going to be defining parameters later on that will allow our scripts to drive the current state of the animator controller. And there's also a layers tab. We currently have one layer, which is the default base layer, and layers in an animator controller work very much like layers in a paint package such as Photoshop, whereas you can create additional layers that will overwrite the animations of layers underneath it. So we could create a layer above the base layer that had a shooting animation, and when that was blended with the layer beneath it, which contained a walking and running animation, we immediately have the ability to have our character walk and run whilst also shooting on a different layer. And you will see later how we use avatar masks so that we can say to a certain layer, we only want the animations on your layer to influence certain body parts. So in the case of a shooting animation, we would say we only want you to affect the upper body, and therefore if there were any running or walking animations playing on the base layer, any of those animations to the legs would be unaffected by us overriding on another layer with a shooting animation. Okay, so enough of that. We'll get to all that in good time. Let's go into our animations folder, drill down into our Mixamo animations folder, and let's look at an idle animation that we can bring in. I think I liked Zombie Idle 1. Let's have a little look at that. Yeah, it's like a kind of alert zombie. So let's drag that into our state machine. And when we drag it into the state machine, it shows up as a state, as a box. And you'll also see that it shows up orange, and that means that this is the default starting state of this layer in the state machine. Now, of course it is, because it's the only state currently in our state machine. But you can also see that it's connected to the entry node, which also signifies that this is the default state that should play. Now, at the moment, that's all I need to do. If I press play, this state machine will immediately start playing its one and only animation clip. And of course, the animator component on our game object will talk to the animator. It says what needs to be animated, and then it will use Jill's avatar to kind of translate that information onto Jill's actual bone hierarchy. So let's press play with the scene view enabled so we can see what's going on. And you'll notice that Jill will idle, but then the idle will stop. Looking good so far. Bosh. Total meltdown. What's happened to her? It's not a big problem. All that's happened is these animation clips that we've imported have not been set to loop. So we need to alter their animation settings so that we can do that. Now, if there's one thing we should know how to do by now, especially after the last lesson, it's how to change the animation import settings of one of our FBX assets. So of course, we can do it the way that we normally do it. We can go to the Mixamo animations folder, and I think we used Zombie Idle 1. And you'll see if you scroll down underneath the animation timeline, there's this loop time checkbox, which is currently unticked. If you tick that, then the animation controller will know that when this animation clip reaches the end of its timeline, then the controller should wrap it back around to the beginning again, and it will play that clip indefinitely. Now, once you've clicked this tick box, you want to scroll down to the bottom of the inspector and click the apply button. Now, there's also another easier way to bring up the animation import settings if you're already working inside the animation controller. So let me just clear the inspector with something else. And you'll see if I just double click the animation state, it will automatically select the asset in the project view and also select the animation tab for me in the animation import inspector. So that's actually an easier way to do it, especially because of this next fact that I'm going to tell you, which is this animation clip is called Jill at Zombie Idle 1. And you can see that when I drag that into the animator controller, Unity automatically gave that clip the same name as the animation. Now the problem is that some of our animation files are going to have pretty convoluted names, and that's going to make for a very messy animation state machine with all of our states being given long convoluted names. But although this was the name that was assigned to it by default, this state can be renamed to anything that we want to make it more readable. So if I left click it once with the mouse, you can see that this brings up the state inspector, and I can just change the name of the state to just idle, I'll call it. And of course, this now changes the name of the state in the actual graph. And of course, you can also see at any point what animation it actually refers to, which is Zombie Idle 1. So I can click the motion field in its inspector and it will take me straight there. So because we can change the name of our animation states, and we often will inside the animator window, it's not always going to be obvious when we're working in the animator window which animation clip this state refers to. And therefore, like, I've just called it idle now, so it wouldn't be obvious to me unless I left click and look at the motion field which animation clip I would need to edit via the animation import settings. So that's why if we just double click on it with the mouse, it takes me straight to the animation import settings of the motion field that's being used. It automatically sets the animations button for me, and it allows me to get where I want to go even if the name of the state is different. So we've now set this animation state to loop. If I go back to the scene view so we can see Jill, if I press play now, we should see her idle away literally forever, or at least until there's a power cut. So there you go. just looping round and round forever. So let's make things a little more exciting now. Let's set up another animation state of walk and set up a transition that's going to change her from her idle state into a walk state. Now, in order to drive that transition, we're going to need some external stimuli. So we'll create a parameter that we can set via code. We'll make it something simple, like a Boolean. So I'm going to go to the animator window, and what I'm going to do is I'm going to add a new Boolean parameter to my animator controller. And when this Boolean is set to true and we're in the idle state, that's going to force it to transition to a walking state. And when we're in the walking state and the Boolean is set to false, it's going to transition it back into an idle state. So it's like this Boolean is going to be a motion Boolean. When it's set to true, we're in motion. So we add a parameter by clicking the parameters tab and then clicking the little plus sign. And we get a choice of 4 different parameter types that are supported by the animator. Float, integer and Boolean are obviously self-explanatory, but there's also this 4th type called a trigger. Now a trigger is like a Boolean, it can be either on or off. But unlike a Boolean, which maintains its state until we manually change its value, as soon as a trigger that has been set to true is used to trigger a transition, the animator controller will automatically reset it back to false again. So it's really good for one of those things where you just wish it to be set once and then reset. But we're going to use a Boolean. And you can see this has added a new parameter to the list, so I'm going to choose its name and I'm going to call this isWalking. The nice thing about the animator window is that without having to write scripts that set this value, we can actually play around with the values in the animator window when the game's running, and we'll be able to see how changing the values sort of updates our graph and which transitions it causes to be fired. So we have the parameter where we want it. So what we want to do now is we want to add a new state, a walking state, to our animator. So I'm going to go into my animations folder, my Mixamo animations folder, and I'm going to drag over that walk animation. There you go. And you can see this is a grey box in the animator, which means that this is not the default state. So if we were to press play now, nothing would happen because there would be no way from the idle state to get into the walk state. In order to do that, we need to create a transition. However, we need to check that the walk state is also a loopable animation. So let's double click on that to bring up its import settings. And yes, it is. This one came in already looping, so there's nothing to do there. Okay, so what we need to do now is make 2 transitions, one from idle to zombie walk and one from zombie walk to idle. And in order to make a transition, we simply right click on the state we wish to make a transition from. We click make transition, and then we move over the state we would like to make the transition to and press the left mouse button. And as you can see now, these 2 states are joined by a wire, and the arrowhead on that wire identifies in which direction that transition is going. So this is a transition from idle to walk. So we're going to need another transition from walk back to idle. So once again, I'm going to right click on the zombie walk state, choose make transition, and do exactly the same thing in reverse. Move the mouse over the idle state, press the left mouse button. So now we need to set up the conditions under which these transitions are going to happen, because at the moment they're going to always happen when each animation clip reaches the end of its timeline. So to show you what I mean, I'm going to drag the animator window down to the bottom of the workspace so that we can see Jill on the screen, and I can also see the animator window updating as the game is playing. So what I expect you to see when I press play is the first thing we'll see a little bar going from left to right on the idle state. This is showing us whereabouts we are in the idle state animations timeline. And when it reaches the end, because we've got no conditions at the moment, it will automatically transition into the zombie walk, and then exactly the same thing will happen again. We will see the timeline of zombie walk move from left to right, and when it reaches the end, it will force the transition back into the idle state. So let's see that happening now. And I'm going to call up the animator window. There it is. There's the timeline bar of idle. There's the transition into walk. And when walk reaches the end, it will transition back into idle, and it will go on like that indefinitely. And of course, this isn't what we want because it's not using our isWalking parameter. And that's what transition conditionals allow us to do. They allow us to use those parameters and the values of those parameters to set the rules under which the transition should happen. So I'm going to work on the idle to walk transition first by just selecting it with the mouse, and you'll see the inspector updates to show us all of the information about this transition. Now, one of the first things you'll see is a property that is currently set to true called has exit time. Now, because we've set no conditions for this transition, this tick box literally has to be set to true. Essentially, it says that this transition is going to happen when the animation has reached its exit time, which is usually the end of the animation clip's timeline. But you do have a choice. If you drop down the settings, you can actually set the exit time, so you could have it transition halfway through the animation if you wanted to. Now, you'll see in a moment that we're going to want to turn this off, but I'm going to leave it on for now just to show you what I mean. Now, underneath the settings, you can see that we have the ability to scrub through the transition timeline, and you can see that we have some cursors here that we can use to set the duration of the blend from the idle animation into the walk animation, so we can see exactly what it looks like blending from one to the next. And I always find, especially from like an idle to a walk, Unity does a pretty good job with the default setup, and we can press play to see what it looks like. Looks pretty good, doesn't it? But if we wanted to make a longer transition, we could do that by just opening up the transition length. And you can see that's kind of way too slow, really, for my liking. So I'll put it back to something like that. Okay, so let's now add a conditional. Now, when we add conditions, we can add multiple conditions. So we could say things like if A equals true and B equals true and C isn't true. So that would be 3 conditions that have to be met for the transition to happen. And we can add as many conditions as we want to this transition by just clicking the plus symbol here at the bottom right corner of the conditions box. So we only need one condition to be met. We need our isWalking Boolean parameter to be set to true. So I'm going to click the plus sign, and because we've only got one parameter defined in this controller, that's our only choice. But if we had multiple parameters, this would open up a drop-down list that would allow us to choose the one that we wish to configure. And because it recognizes that I've chosen a Boolean parameter, it automatically provides me with a true-false drop-down. So to go from idle to zombie walk, I wish this condition to be true. If isWalking is true, then this transition should happen. So that transition is set up. Let's now select the other transition, which takes us from zombie walk to idle, and add the condition there too. Of course, this time we wish the opposite to be true. We wish to go from a walk into an idle when isWalking is set to false, like so. So I've set up both of these transitions, and when I press play in a moment, you're going to see that I can watch this happening in the animator window by just turning on and off the isWalking Boolean. So I don't have to bother writing code to do it. So let me just adjust my camera view, and you're going to see there's a little problem with this, which is linked to us having that has exit time ticked in the transitions. So let me press play and call up the animator window, and I can talk you through what's happening. Now notice when we get to the end of the idle animation, it's automatically wrapping around now. It's not automatically transitioning into zombie walk because the isWalking Boolean condition has not been met. It needs to be set to true. But notice if I wait until it wraps around and then set it to true, I'm going to have a long wait before the transition happens. There you go. I've set it to true, and it's not going to transition until the end of its timeline. So now I'm in walking, and this is going to happen again. If I wait for it to wrap round and then untick the Boolean, like so, it's going to carry on walking for a few steps until it gets to the end of its cycle before it transitions back into idle. And of course, that's not what we want. If we were controlling this character with a joypad, we wouldn't want to have him standing still, push forward on the joypad joystick, and then have to wait 3 seconds for the guy to actually start moving. And this is all because we have that has exit time ticked in each of these transitions. Now, there will be times when you want this to happen, and it's more often used when you don't have any conditions, when something has happened which has forced us to go into an animation state which must fully play out to its entirety. But that is not the case here, so I'm going to untick that box from both of those transitions, and then I'm going to press play again, call up the animator window, and you're now going to see that as I toggle the isWalking Boolean on and off, it's an instant transition and it instantly stops. Turn it on again and turn it off now. Turn it on again and turn it off now. And if you think the transition is too fast, especially from the walk to an idle, then we could just go in there, we could just make that a little bit longer in its duration. So let's see what that looks like now when we go from a walk back to an idle. It should be much slower. So here we are in the walk. I'm going to click it off now. In fact, that does actually look better, doesn't it? I like it better with him going from idle to walk much quicker, but I do like the slowdown being better. There you go. So we'll leave it like that for now. Okay then, so let's take this simple example a step further and add some animations to allow our character to turn left and to turn right. And we'll have this controlled by an additional parameter, which will be an integer that if set to -1 will turn the character left, and if set to 1 will turn the character right. Now we're going to need to do some editing to our turn animation, because when we went to mixamo.com and we downloaded our zombie turn animation, you will remember, if I go to the Mixamo animations folder, and down the bottom here we have this Jill zombie _ turn, you will recall that this was only a one directional turn. The zombie just turned right. So we need to make a duplicate of this clip and mirror it. And that's really easy. I mean, we don't need to make a duplicate copy of the actual asset. We can do that from inside the FBX import settings. Now you can see at the moment that when this came in, it had a single animation clip created from its timeline. The timeline contains the entire turning clip. So let's press play, see which direction he's turning. He's turning right. So let's rename that clip and call it Zombie Turn Right. Okay. Now what I'm going to do is I'm going to go first of all, I'm going to set the loop time. We wish our turning to loop so that if we stay in the looping state, he will keep turning round and round and round until we wish him to stop turning. And now what I'm going to do is I'm going to press the plus sign again at the bottom of the clips window. And this is going to create another animation from this FBX file using whatever section of the timeline I've got highlighted. I'm going to leave it with it all highlighted. So I'm essentially going to create a complete duplicate of what we've already got. And as you can see, Zombie Turn, a new animation clip, has been added to the clips list in the importer window. So I'm going to call this Zombie Turn Left. And then what I'm going to do is I'm going to set the loop time on that animation so that it loops. And then I'm going to scroll down to the bottom and I'm going to click this mirror tick box. And if I press play in the preview window, now we have the zombie turning left. If I click apply, we now have a left turn zombie. And we have a right turn zombie, like so. And if I open up the FBX file now in the project view, you'll see that we now have two animation clips that are under that FBX asset in our project view. So we can just drag those into the animator window. So I'm going to move the animator window up to the top again so that I have the project view and the animator window open at the same time. And I'm going to drag in the zombie left state, like so. And I'm going to drag in the zombie right state, like so. And then I'm going to create a parameter, add a new parameter to our parameters list. And I'm going to make this an integer, and I'm going to call it turning. And then I'm going to create a transition from our idle state to the zombie turn left state, a transition from the idle state to the zombie turn right state. And then I'm going to create transitions back in the opposite direction from both of those states. And then we will go in and we will edit them. So with our current graph, what we're saying is that if the zombie is walking and we wish him to turn, he will transition back into idle first and then transition into one of the turn states. And we want to do that because our turning state isn't a walking and turning state, it's a turning on the spot state. So that's why we'll transition them back to idle first so that the zombie will walk, come to a stop and then begin to turn. So what's the condition under which we're going to turn left? Well, we're going to turn off the has exit time, because we wish to start turning immediately from the idle state when our condition is met. And our condition is simply going to be, and notice I pressed the plus sign in the conditions window to add a new condition, and from the drop down I now have two choices, and we want to choose the turning parameter. And because it's an integer, it's given me some different controls to work with, and we're going to turn left when that integer is -1. So we will say turn left when it is less than 0. Then I'm going to go to the transition from idle to turn right, and I'm going to say, I want you to turn left. I'll untick the has exit time again, and I'll choose the turning integer as our conditional parameter, and we'll say greater than 0. So we now know that if turning is -1, it will go to zombie turn left, and if it's +1, it will go to zombie turn right. But we also need to make sure that if we're turning, we don't transition to the walk. So we need to essentially add another parameter to the condition that we currently have that transitions us from idle to walk. Because at the moment we just say if is walking is true, then go to the walking state. But is walking might be true, but we may also be in the middle of turning, in which case that's going to kind of override the behavior of the walk. So what I'm going to say is only transition into a walk if is walking is true, and then I'm going to add another parameter that says turning equals 0. So I'm saying go to the walk animation from idle if we're currently walking and we're not turning. Okay? So what we've done is we've got one transition from idle to zombie walk in which two conditions have to be met for that transition to happen. What we're going to do with the transition from zombie walk back to idle is we're going to add another transition. You see, this transition here is fine. We always want to transition from zombie walk to idle when is walking is set to false. But there's another condition under which we wish to transition from walk to idle, and that's when our turning integer is non-zero, which means that we're turning. So in order to do another transition, rather than what we did below, which is a single transition with multiple conditional parameters, I just go to the zombie walk state, select it with the left mouse, right click with the mouse, choose make transition, and drag another transition over to idle. And you'll see now that there are multiple arrowheads on the transition from walk to idle, and that's what lets us know that there are multiple transitions between these two states. So if I click on the wire now, we have two transitions now in the transition list, and as you can see, the first one is the one we had before that is triggered by the is walking boolean being set to false. But we also have this new transition now, so let's set that one up, and we don't want it to have an exit time. We want this to transition back to idle whenever turning is non-zero. So I'm going to add a conditional. I'm going to set it to turning, and I'm going to say when it doesn't equal 0, which means we need to immediately abort our walk animation to transition back to the idle animation. And then once we're back in the idle animation, that animation will pick up that turning is either 1 or -1, and then transition either to the left turn or the right turn animation clips. So let's test this out. Hopefully I've done everything right. I'm going to drag the animator window down to the bottom, and I'm going to control this once again by just clicking the parameter settings in the animator window rather than write a script to set these. We're going to be writing scripts to do that in a moment, but for now this just allows me to test it quite simply. So if I call up the animator window, you can see that we're in the idle state. Now if I set turning to -1, hey, look at that. You saw the transition happen to our zombie left turn, and if I set it back to 0 again, it just goes back to the idle state. And if I set it to +1, he turns around the other way. Now if I set walking to true, the character will not start walking, and that's because in that transition from idle to zombie walk, we said only make this transition if we are not turning, if turning equals 0, which of course it doesn't do in this condition. So in order to have us walk, we need to set turning to 0. So let's do that. And now he's going to begin walking. Okay, so that seems to work. So let us take this a step further by adding one of our zombie attack animations to the state machine. Now one way that we could do this is we could drag the animation clip into our base layer and make a load of transitions to it that are powered by a parameter called attack. But I'm not going to do that because our attack animation is an animation that plays when the zombie is at a standstill. Therefore, if the zombie was walking or turning, and we then chose to play the attack animation, that other animation would come to a stop, so he wouldn't be able to walk and attack at the same time. And I don't want that. So what we're going to do instead is we're going to add a new layer to our animator, and we're going to do that by going to the Layers tab and clicking this little plus icon. And as you can see, this has created a new layer above the base layer. Now I know what you're thinking it's below the base layer, so you kind of have to think of this as working the opposite way round to layers in Photoshop, whereas the base layer is the topmost layer, and as you work down the list, those layers play on top of layers above it. Okay, I'm going to call this layer attack. I'm also going to create a new Boolean parameter, and I'm going to call that attack as well. So with the parameters tab selected, I'm going to click the plus sign, and I'm going to add a new Boolean, and I'm going to call that attack. Actually, I'm going to go back to the layers tab, and I'm going to change the attack there to attack layer. Okay, I don't want us to get the two confused. One's a layer, one is a parameter. So now you can see that the state machine has changed and is now showing us the contents of the attack layer, which is an empty layer. It's got no states added to it. And we can see what any layer looks like by simply clicking on the layer in the layer list. So there's our base layer. If I click the attack layer, it's completely empty. So now I need to find an attack animation that I wish to use. So I'm going to go to the project view. I'm going to drill down into my animations folder, my Mixamo animations folder, and let's find a nice attack animation. There's one here called Zombie Attack 1. Let me look at that in the preview window. Yep, I like that. So this currently is not a looping animation, and we want the character to continue to attack while that attack boolean is set. So I'm going to set this to be a looping animation, then click apply. Then what I'm going to do is I'm going to drag my animator window up to the top so I can see the animator window and the project view on screen at the same time. And with my attack layer selected, that's important. We don't want this in the base layer. We want it in the attack layer. I'm going to drag that animation over. So it was called Zombie Attack 1. Now at the moment, we're going to have a bit of a problem when we press play. In fact, we're not really going to see anything happen. As you can see, the attack animation is being ignored. The reason for this is that all layers, except the base layer, can have a weight assigned to them. This basically controls the strength of the contribution of the animation clip currently playing in that layer on the final bone hierarchy. So it allows us to control how the animation clip in the attack layer blends with the animation clip currently playing in the base layer. And in order to set the layer weight, we have to click this little cog sign on the layer itself, and this allows us to adjust the layer settings. And as you can see, the weight of this layer is set to 0. So let's move that all the way up to 1, which basically means that the animation clip in this layer is going to override any animation clip that might be currently playing in the base layer or any other layers that are underneath it in hierarchical order. So let's test that. If I press play now, the base layer should be completely ignored and we should just see this attack animation playing out. So I'm going to call up the scene view so we can see what's happening. There you go. And because it's a looping animation, it should just carry on doing that forever. Now, just to show you how it works, if I call up the settings for the attack layer again and set that to say 0.47, we're only going to see that contributing at half strength. So the pose of the skeleton in this animation is going to be essentially blended with the pose of the skeleton at the current frame in the animation playing in the layer underneath it. So we're going to see a blend between the two. So the swipe will still happen, but it's going to be much less pronounced because it's been diluted by the idle animation. There you go. So that's how layer weights work. But of course, when the player attacks somebody, we want the full attack swipe to happen. But what we don't want to happen is we don't want this animation to always be playing. We only want it to trigger when the attack boolean is set to true. So in order to do that, we need to make the attack layer not do anything until this condition is met. So what we're going to do is we're going to create a brand new empty state in that layer. We right click, we choose create state, and then we choose empty. And this empty state basically is going to do nothing to the hierarchy. So while this empty state is playing, the base layer animation clips will have full control. And what I'm going to do is I'm going to make this the new default state. So when I press play, in the attack layer, we're just going to be endlessly stuck in this new state, which is going to have no effect on the hierarchy at all, and the base layer will animate the bone hierarchy exactly as it did before, unaffected by the attack layer. So let's test that out. So I'm going to move the animator window down to the bottom of the workspace, and then I'm going to press play. And we should see him idling, just as he did before, until we set the isWalking boolean. Then he'll begin to walk, but we can also override that at any time by setting the turning integer to 1, which makes him turn right, or setting it to -1, which makes him, or her should I say, because her name's Jill, turn left. But of course at the moment, if I click the attack boolean, nothing is going to happen at all. And of course that's because in our attack layer we have this empty state that's playing endlessly, and we've set up no transition to transition into the attack state. So let's do that now. So I'm going to right click and choose make transition. I'm going to make a transition to the attack animation. And then I'm going to create another transition from the attack animation back to our empty state. I think what I'm also going to do is I'm going to rename that new state and call it empty state, because I think that makes it a little bit more readable and lets us know that it's actually doing nothing. There you go, that's better. So let's now edit the transition from the empty state to the attack state. Now we don't want to use the has exit time boolean. As soon as that attack boolean is set, we want to immediately transition from the empty state into the attack state so there's no delay. And of course we need to set the condition, and the condition is simply going to be when the attack boolean is set to true. Now we want to edit the other transition back from the zombie attack state into the empty state. Now this time we want the attack animation to fully play out. We don't want the character to immediately transition back to an empty state if it's only halfway through a swipe of a right hand. So we are going to leave has exit time ticked, but what we are going to do is also add a condition which is attack equals false. That way, when we transition into the attack state, if we leave the attack boolean set, this attack state will keep looping around and the zombie will keep swiping at us. But the minute that we untick that attack boolean and we set it to false, the attack animation that's currently playing will play out into its entirety, and then it will transition back to the empty state. So let's see what happens now if I press play. So if I press the attack boolean, hey, look at that. And then I untick it. Actually, that was a bad test, so let me wait until she begins to attack and then I'll untick it. You can see she carries on the swipe and only transitions back to the empty state when the attack is fully over. Now, we do have a problem at the moment. You see, if I set is walking and then I click the attack state, that's going to stop her while the attack animation plays. And of course, that's because the attack state is totally overriding any of the animations being performed on the bone hierarchy by the state underneath it. What we want to do is we want this attack animation to only affect the upper body of Jill, and therefore if she's currently walking, she will carry on walking and attack at the same time, or if she's turning, she'll be able to turn and attack at the same time. And in order to do that, we need to use avatar masks. So if we go back to the Layers tab in the Animator window, and we select our attack layer, and once again click on that little cog which brings up the layer settings, you'll notice that underneath the weight property there is another property where we can assign an avatar mask. Now we haven't created any masks in our project, so let's create one that is going to tell this layer only the body parts that we wish it to affect. So I'm going to go to the project view, I'm going to go to my Dead Earth folder, and I'm going to create a new subfolder, and I think I'm going to call this Avatar Masks. I'm going to drill down into that folder, I'm going to right click, and I'm going to choose from the Create submenu, Avatar Mask. And I'm going to call this mask Attack Mask. So we have created an avatar mask asset in our project view. So if we select that and look in the inspector, you'll see that there is a humanoid drop down and a transform drop down. And as is the case with many things with Mechanim, there is a specialized workflow for working with humanoid rigs. So we're going to use the humanoid drop down. So if I open it up, you'll see that we have a graphical representation of the avatar. And the way that it works is that if we assign this to a layer, any body parts that are green will allow to be influenced by the animations on that layer. And any that are red will not be allowed to be animated by that layer. So what we want to do is essentially turn off all the body parts underneath the waist. So I'm just going to click on them to turn them red. And now when we assign this mask to our attack layer, we are saying that whatever animation you're playing, throw away any animations that touch the leg bones. We just want you to animate everything above the waist. So in order to assign that to our layer, it's easy. We just go back to the animator view, we click on our attack layer, and once again we click on that little cog icon that is going to bring up the layer settings. And underneath the weight property, you can see there is a mask property. We currently have no avatar mask assigned, so let's click on that little circle there to bring up the avatar mask picker dialog. Now we only have one avatar mask in our project, so that's the one that's being shown. It's called attack mask, so I'm going to double click it to assign it to this layer. Now I'm going to press play. So if I bring up the parameters tab, we can see that if we click the attack boolean, it does correctly swipe. But notice it's different. The legs are still playing the idle animation. They don't change or snap. In fact, the leg motion in the attack clip is being completely discarded by the avatar mask that we've assigned to that layer. Let me prove it to you. What I'm going to do now is I'm going to get the zombie to turn whilst playing the attack animation. Pretty cool, huh? Or turn the other way. So the legs are being driven by the base layer, the torso is being driven by the attack layer. And finally, I guess our one check is, can we have him walking and attacking at the same time? And yes, indeed we can. Good stuff, isn't it? So that's why layers are really, really useful. And we've also seen how to use avatar masks for the first time as well. And the great thing about it is if I go back to the layers menu and call up the attack layer, you can see it has this little M next to it, which lets us see just at a glance that this layer has a mask assigned to it. So we have the ability to not only mask out body parts, but then also for the body parts that are going to be animated by this layer, to control the strength of influence of the animation clip. So if I put this to, I don't know, let's just say halfway again, and then press play and call up the animator window and the parameters tab, you can see now that while he's walking, if we click the attack, the arms aren't going to sort of fully play the attack animation because they're being blended with the animation that's being done for the arms from the base layer. And hopefully you understand how these layers now work and how they can be used to do a multitude of things. And in fact, in Dead Earth, when we complete our zombie AI state machine, we are going to have probably 6 or 7 different layers, all controlling different aspects of the zombie's personality. Now, in a game, we don't generally have one locomotion speed for our characters. We might have several walks, several runs, a jog, a trot, and transitioning from one state to the other is not always what we need to do. Yeah, we could have some speed parameter that is used to say if it's greater than a certain amount, then transition from a walk animation clip to a run animation clip. But these things are generally handled using blend trees, and that's what we're going to talk about next. With a blend tree, we can assign all of our locomotion animation, such as walk and run, and then we can have that blend tree driven by a parameter that I'm going to call speed. The blend tree will blend the walking and the running together based on the value of speed, so that as we increase the speed slider, we see the run slowly turn into a sprint or the walk slowly turn into a run. So in order to demonstrate this, I'm going to delete everything that we've got in our base layer except the idle state, and I'm not going to use zombie animations for this. I'm going to use those animations that we imported in the zip file that accompanied this lesson. They're just generic humanoid walk and run animations. And I'm also going to delete the isWalking parameter and the turning parameter. I'm going to leave the attack parameter in there for now, but I'm going to create a new parameter, and that's going to be of type float, and I'm going to call this speed. And then with the speed parameter selected, I'm going to right click in an empty area in the animator view, and I'm going to choose create state, and instead of creating an empty state, I'm going to choose from new blend tree. As you can see, this has created a new state in the animator called blend tree. I'm going to rename that and call that locomotion, as this is going to be the blend tree that controls my walk to a run blend. Then I'm going to set a transition that goes from my idle state to my locomotion state, and I want that transition to happen when our speed is greater than 0. So just to allow for a bit of floating point error, I will make that condition speed and say greater than 0.1. So we wait until we've got a little bit of movement before we start to transition into the locomotion state. Now let's have a look what the locomotion state, which remember is a blend tree, looks like inside. At the moment, all you can see is a slider called speed. But if we look at its inspector, we can see that there is a list which is currently empty where we can assign motion fields. In other words, animation clips. So I'm going to create 2 animation clips. So I say add new motion field, add new motion field. And then I need to assign some animation clips to those motion slots. So I'm going to go to my project view, and I'm going to drill down into the Unity Technologies folder of the animations folder inside my Dead Earth folder. And in the top slot, I'm going to drag in my walk forward animation. So this is called default avatar at walk forward, neutral face forward. I'm going to drag over the walk animation clip. And then I'm going to go to the default avatar run forward, neutral face forward, and drag over, oops, let me call up the blend tree again. You can see it's already assigned the walk state to our blend tree. So if I go back to the project view again, making sure the blend tree is selected, so I get it in the inspector. I probably should have locked the inspector then, and then I drag over the run clip into the motion field. So let's call back up the animator window, talk a little bit about what we've just created and what a blend tree actually is. So the idea of a blend tree is that we can create a list of animation clips and then blend between them based on the value of a parameter. Now, in the case of a one-dimensional blend tree, which you can see is what we've selected here, the blend all happens on the value of a single parameter. In our case, a parameter called speed. The animations in the list are all mapped to a specific range. Now, in our case, because we've set automate thresholds, it's been mapped to the 0 to 1 range. So you can see that when speed is 0, the threshold for our walk animation, the walk animation clip will be getting played. At a speed value of 1, which is the threshold of the run animation will be getting played. But at a speed value of 0.5, we're going to see a blend of the walk and run in equal measure. And why this is really cool becomes evident when I press play and see what happens when I adjust the speed slider. So we start off with a speed of 0, which is triggering our walk animation. So we start off with a speed of 0, which triggers our walk animation clip. If we slide it up to 1, then our running animation clip is playing because the threshold at which run is fully weighted is 1, as we can see here in the threshold list. However, if we start to degrade the value stored in speed, you'll see that rather than just snap into a walking animation, it slowly blends from a walk and then back up to a run. So it's almost like we have an infinite variety of variations between the two animation types, so that we can have a zombie that, if is damaged, perhaps can only run at half its maximum speed, like so, or one that's overly aggressive running at full speed. So this single state is a blend tree, and at the moment, because we told it to automate the thresholds, it's setting the range of the speed value to be in between the 0 to 1 range, and depending on that value it will blend in the appropriate amounts of the walk and run animation clips together. Now if you look in the animator window, you can see that when speed is 0, the wire is completely blue that is connecting the walk animation to the blend tree. This is letting us know that the walk animation is fully in control of the rig. And if I set the speed up to 1, you can see that now this wire is blue connecting the run animation clip to the blend tree. And you can see that as I begin to slide down the speed slider, we see both of those wires highlighting a lesser intensity blue, which lets me know that both of them are being blended together to some degree. Normally, we don't want to control the speed of a character by just setting a speed value between 0 and 1. For example, if we were using the nav agent to drive this character, now one of the things that we might actually want to do is actually fetch the speed that the nav agent is actually walking at, and then set that as the speed parameter to our blend tree, and then let the blend tree choose the correct animation to match that speed based on the root motion contained inside the animation clip. And there's a really easy way to do that. What we have to do is just untick automate thresholds, and then there is this compute thresholds drop down, and you'll see the top option is speed. What this will do is it will analyze the animation clips that we've assigned to the motion fields, and in particular the root motion stored inside them, and will actually compute the speed and set their thresholds accordingly. So let's press speed and see what happens. As you can see, it's detected that when the run animation is fully playing, the root motion describes the character as moving at 5.66. I guess that's kilometers per hour, maybe, I don't know. And the walk animation at 1.55. And you can see now that if I move the speed slider, it now goes between 1.56 and 5.66. So the same blend is still happening. It's still blending equally and smoothly between each one, but now it's using proper values. And you can imagine now the power of that speed parameter of what we're actually sending in from our code is the true speed the object is moving, and allow the blend tree to select the correct animation, or at least the closest one that it can find that actually matches up with it. Now the thresholds can be manually adjusted too, and in order to manually adjust the thresholds, you can just double click on any threshold and set the threshold at which you wish that animation to be fully weighted. So if I set run to 3, for example, like so, in this case it doesn't really do a lot because there is only 2 animations, so 3 now becomes the maximum limit. But you can assign any number of animations. Let me just show you what I mean. If I go to my project view, go back to my Mixamo animations, and bring in that zombie walk animation into the motion field. And in order to do that, I need to click plus on the motion list, choose to add a new motion field, and then I'm going to drag in my zombie walk animation clip, which I'm assuming is going to be slower than just a standard walk, and I'll drag that up to the top so I have them in order from slow to fast. And then I'll do automate thresholds on speed again, and there you go. Now you can see the shape of the blending in the top of the inspector looks very, very different because it detects at only 0.025. Then that is when the zombie walk is fully weighted, but then it will blend from zombie walk to a standard walk and be at a standard walk fully at 1.5, and then a blend from a walk to a run at 5.6, where run is fully weighted. So let's see what that looks like by bringing up our animator window, and we'll start with our zombie walk. Now these animations aren't really particularly well suited to blend together. A zombie walk into a standard walk might not look very good at all. So let me pull up that slider and see what happens. Yeah, it's not so good, is it? But it's good enough to prove my point. So we can go from that, and then he sees somebody, he starts to walk and go, what's that? Then he sees you and it's like, I'm coming for you, buddy. So you can add any number of animation clips to the motion field list. And like I said, if you use any of these compute thresholds, you can have your thresholds automatically computed based on some real world values that you might send in, like speed or horizontal speed, forward and backward speed, or vertically up and down speed, or even have the threshold set based on the rotational speed that's stored inside the animation. And you can imagine that would be good if you had a blend tree that contained several different speeds of turning left and right. You could actually feed in the rotational speed that the object is actually turning at and let the blend tree choose the correct rotation to match that rotational speed. So what I'm going to do is I'm going to delete that zombie walk from our motion field list because it kind of sucks. And I do that by selecting it and then clicking on the little minus sign in the bottom right corner of the motion field list window. There you go. And then I'm going to click speed again just to compute the thresholds. I don't think there was any need to do that. And then what I'm going to do is I'm going to press play. Oh no, I'm not. We haven't set up the base layer yet. So in order to get back up out of the blend tree and into the base layer in which it's contained, we have these kind of breadcrumbs along the top. So you can see we're currently in the locomotion field. If we click on base layer, that takes us back up into the base layer. Now we set up the transition from the idle to the locomotion blend tree by saying if speed is greater than 0.1. So what we need to do now is set a transition back from our blend tree into an idle state if speed is less than 0.1. And I want to add a new conditional speed and say we wish to change down into an idle if speed becomes less than 0.1. And now we have the ability to go from idle to our blend tree and from our blend tree back to idle. So if I press play now, call up the animator window and start typing in some values, like a value of 1 for example, he walks, a value of 3, kind of like a jog, and a value of 5, kind of like a sprint. But it's kind of hard to see what's going on here because our character is just going to run off the side of the screen in the scene view, and our game view doesn't really tell us what's going on. So what I'm going to do is I'm going to create a mount on the character's head, and then I'm going to write a small script for our camera that's going to make it kind of attach itself to that mount so that as the zombie moves, our camera smoothly moves with her. So let me find Jill's head first of all in the hierarchy. So I'm going to drill down into her bones, hips, into spine, spine 1, spine 2, neck, neck 1, head. Finally, there she is. And what I'm going to do is I'm going to create a new empty game object. I'm going to create a new empty child. So that's going to be right on the position of the head. And I'm going to rename that head cam. Oh no, I'm not. I'm going to call it head cam mount. Like so. And then what I'm going to do is that's going to be facing the wrong way at the moment. So all I've done is positioned the scene view, but I've still got the head mount cam selected. So what I'm going to do now is I'm going to use a nice little shortcut to position and orient that head cam mount so that it is exactly the view that I am now looking at it in the scene view. And we do that by going to the game object menu and do align with view. And as you can see, that game object I had selected is now exactly where our scene view was positioned and rotated when I assigned that menu command. So this is where we want the camera to be. So what I'm going to do now is I'm going to write a script that I'm going to add to my camera that's just going to kind of move it to this mount but it's going to do a smooth lerp to that position and rotation, so that when the camera moves around and the head is looking up and down, our camera isn't being thrown all over the place. So our camera is in the navigation example geometry folder. So let me pull that out and put it in the root. And then what I'm going to do, because this is just going to be a test script that we're not going to keep around for long, is I'm going to create this in my scripts folder, and I'm going to call this smooth camera mount. So create new C# script, smooth camera mount. And I'm going to drag that onto my main camera, like so. And then I'm going to open up that script in MonoDevelop. Okay, so the first thing I'm going to do is declare a public variable of type transform, and I'll call this mount. And this is where we're going to assign a reference to that camera mount that we just created and attached to the GeoCharacter. I'll set this to null by default. And I need another public variable of type float, which I can use to set the speed at which this camera is going to update to match the position and the rotation of the mount. So this is going to be a float. I'm going to call it speed, and I'll set its default value to, I don't know, 5. Then what I'm going to do is I'm going to change the update function to be the late update function, which means it's going to be called after all of the objects in our scene have had their update function called. So we'll know that everything has already been updated, and we're going to be updating the camera to the very latest positions and rotations of all of our characters. And the first thing I need to do is I'm going to calculate the new position of the transform of our camera, and I'm going to set that equal to a lerp between the current position and the position that our mount is currently at. So to do that, I use the vector3 lerp function, and I want to lerp from the current position of the transform, and I want to lerp towards the position of the mount. I'm not doing any error checking here to make sure that we haven't got any null references, okay, because this is just a temporary script. And the t value for the lerp is going to be time.delta time. Now we know that that would do a lerp from the source to the destination over 1 second, which is going to be too slow. So we'll then multiply that by our speed value. And then we need to do a very similar thing to match the rotation of our camera to the rotation of the mount. And because rotations are quaternions, we're going to use a quaternion slurp for that. So I'm going to say the transform.rotation is equal to quaternion.slurp transform.rotation mount.rotation. And then as the t value, once again, time.delta time multiplied by our speed modifier. Okay, no idea what this is going to look like. So if I go back to Unity now, oh, I've got an error. What is it? Oh, what an idiot. That's supposed to be mount. Mount is already a transform. I need to see mount.position. Okay, now, there you go. Then we should have no errors. And then what we need to do is we need to select our camera in the scene. Where's it gone? There it is. And there's our script, which now has that speed property and an unassigned mount. So we need to drag over that head cam mount that we added to Geo's head and make that reference like so. And now let's press play and see what happens. Okay, maybe the head wasn't the best bone to connect it to, because as she rotates her head, which she obviously does quite a lot in these animations, our camera is turning with it. So I think what we'll probably do then is we'll connect it to the chest bone instead, which is probably going to move a lot less, at least rotate a lot less from side to side. So we'll go to maybe, I don't know, maybe spine 1. And then what I'll do is I'm going to go behind the character as well, I think. Something like that. So I'm going to select that head cam mount and do what we did before. Remember, that's the head cam mount now that we see. It's in front of the character. I really want it behind the character, I think. So with the head cam mount selected, I'm going to go to the game object menu and once again choose align with view. And as you can see, there it is now behind her. Let's see if that's a little bit better. That's much better, although I think I'm now going to manually move it down, because obviously what happens is when the animation plays, I guess the spine bends and it makes the camera a little bit too high. I think I'll just move something like that. Okay, that looks pretty good. So what I want to do now then to test this out is I want to drag my animator window up to the top again so I can have the game view active and I can play around with my animator parameters and check that they're working. Oh, I must also remember, not that we need to use it in this, that my attack layer, remember when I was showing you the weight, it's currently only set to half weight. That needs to be back up to 1 so that we get a full attack when we're in play mode. There you go, like so. Oops, accidentally pressed stop there. Let me press play again, sorry. So I'm going to set the speed to 1 to begin with. There's a kind of a walk. Go to 0.5. She's going to walk through geometry at the moment, guys. Don't worry about that. 2.5. 3.5. 4.5. 5.5. And now she's in a full run. And if you want to see what 5.5 looks like, well, there's still some geometry to test it against. There you go. Oh, I do love root motion. Okay, it's pretty hard to control with just typing in values into the parameter slots in the animator. So what we'll do now is we will create a script that we're going to add to Jill, and we're going to expose a slider on that scripts inspector that will allow us to slide the speed up from maximum to minimum. And the nice thing about this is it's going to show you how from our scripts we can communicate with the animator controller and set those parameters. So I'm going to go back to the project view, into my scripts folder, and once again this is just going to be another temporary C# script, and I'm going to call that speed controller. I'm going to assign that to Jill. Now this needs to be assigned to the same game object, which is Jill's top level object, that has the animator component attached to it, because this script is going to talk to the animator and use its functions to send parameter values into the animator controller. So let's move over speed controller and let's open that up in MonoDevelop. So what we want then is a public variable, a float that I'm going to call speed. Now this doesn't need to match the name of the parameter that we've defined in the animator controller. They're totally separate. So I could call it anything I wanted, but I'm going to call it speed. So this is going to be a public variable and it's going to be of type float, and I'll call it speed with a capital S, and I'll set this to 0 by default. Now this script is also going to need to be able to talk to the animator component that is on this game object, so we're going to need to cache a reference to that. So that doesn't need to be public, so I'm going to create a private variable of type animator, and I'm going to call this controller. I use that underscore and the first letter uncapitalized for my private variables, and I set this to null by default, but then in the start function I'm going to grab a reference to that by saying controller equals get component animator, like so. And then in the update function, I can use the controller set. Now it's got a series of set functions for setting the variables of different types. So you've got set bool, set float, set int. So I'm going to do set float because my parameter is a float, like so. And this takes two parameters. The first one is the name of the parameter, which is called speed. I think I used did I use a capital? And then the second parameter is the actual value that we want to send in, and of course that is our actual speed member of this class, like so. And we can now press play and see the speed happening. So we just need to move the mouse over the speed word and then start increasing the speed, like so. Dun, 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 dun. Now you can see right now I'm up at 11 for speed. Now we know that there is no animation that matches 11, so in that particular case it's just maxing out and choosing the fastest speed that is available that matches the speed of 11, which in our case was our run speed, which I think was about 5 point something, wasn't it? Then as I begin to slow her back down again, hey, look at that. And then back down to 0. We can see in the state machine transitions. I can, at least if I pull up the correct layer, it goes back to an idle. Pretty cool, huh? Okay, so let's do another demonstration now that uses a two-dimensional blend tree. That's where two parameters are used to choose the appropriate animations to blend. And what we're going to do in this example is we're going to use Unity's input to control the character Jill. And if you've used Unity's input before, you'll know that we have a horizontal axis and a vertical axis, and they describe the position of the controller in the -1 to +1 range. So I'm going to be using the cursor keys, and I'm going to have to create some parameters that I can pass in the state of the horizontal and vertical axis of the controller. So I'm going to delete my speed parameter, I don't need that anymore. And I'm also going to delete my locomotion blend tree, we won't need that anymore. And I'm going to create two more parameters, both of type float. The first one I'm going to name horizontal, and the second one I'm going to name vertical. Then I'm going to set up a new blend tree by right-clicking in the animator window, choosing create state and choosing from new blend tree. And I'm going to rename that locomotion again. And this time I'm going to double click on it and I'm going to change the blend type from 1D to 2D freeform Cartesian, like so. Now, if you look at the parameters at the top of the inspector, we get to choose the two parameters that drive it. So I'm going to choose the horizontal parameter and the vertical parameter. And when we look at the blend tree, we now have two values that we can choose from. So let me show you the animations that I'm going to use for this example. And they are in the Unity Technologies folder. So we have this run animation and we have a walk animation. And we used those in the last demonstration, but what we also have is run left and run right in various different versions. So if I make my way down the list, I'm going to go in order actually. So I'll start from walk. We have walk left short. This is where it turns really tightly on the spot, and walk right short. Exactly the same in the opposite direction. Then we have walk left medium, where he walks to the left and the right respectively, but in a wider arc. And then we have walk left wide, which is a much more shallow angle of turn. And we also have similar things for the run as well. We don't have a short, but we have a run left medium. And we have a run left wide. So we're going to put all of these animations into a two-dimensional blend tree. And we're going to configure the blend tree based on speed and angular speed. And then the blend tree will automatically choose the correct animations to blend between based on the horizontal and vertical positions of our controller. So how many animations have we got here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we need to go back to our blend tree and we need to create 12 motion fields. Wow. So add motion field, add motion field, add motion field. Okay guys, I'm going to pause the video while I'm adding these, alright? Okay, there you go, I've added all of the motion fields. I'm pretty sure there's a shortcut way to do that, but right now it's completely escaped me. So we need to assign the animations to the motion field now. Now it doesn't matter the order in which we copy them over, so I'll put run left medium, run right medium, run left wide, run right wide, walk left medium, walk right medium, walk left short, walk right short, walk left wide, walk right wide. Phew. Okay, so if you look at the top now, instead of having that sort of linear blend from one animation to the other, what we have is a two-dimensional positioning of these animation clips. So what we need to do is we need to let Unity automatically position the various animations in this sort of 2D graph based on those parameters. So let's tell it what we wish to use for those calculations. And what I'm going to use is speed and angular speed, like so. There you go, it's done. And you can see each one of these dots now is one of our animations. And if I press play and move this red dot about, you'll see what I mean. So it's like it represents the joystick position. So here it's just walking forward. If I move it over to the left, it's going to trigger the shallow left turn. If I move it over, and again, it's going to trigger the medium left turn. And if I move it far over to the left, it's going to trigger the steepest left turn. As I push it forward, we start to blend with the run invariance of the animation. So here we're getting a run left medium, move it into the middle, just a straight run, then over to the right, the steep right turn. And of course we can just drag it around everywhere to see how all of the animations blend into one another. So it's really cool. Okay, of course we can also control this via our blend tree sliders. So if we set horizontal to 0, then we've got pretty much what we had before, where at 0 we're just walking, and at 5.66, which is the maximum speed taken from our running animation, from the root motion, you can see he's running, and anywhere in between that is a blend between walk and run. But now we're blending as well on the x-axis, so we can have a run, but then we can also move this slider to the right, and look at the red dot as I move the slider. You can see that if I set it to about 0.94, it's exactly halfway between the run forward and the shallow run to the right. If I go over to around about 1.7, it's fully weighting the right run animation. And if I go right over to 2.32, it's fully now using, actually if I just pull back a little bit, like so. At that point, at 5.24 speed and 2.32 horizontally, we're getting the tightest turn that we can possibly do, which is the run right medium is playing there. Okay, so you get an idea of how this works. What we need to do now is we need to set up the transitions that's going to take us into this locomotion setting. And like I said, the horizontal and vertical parameters are actually going to be set via script. Let me stop that preview playing. So we need to create some transitions that's going to take us in and out of the idle state. So we're going to go from idle to locomotion, and I'm going to turn off has exit time. And what we're going to do is we're going to say we're going to go into the blend tree if our vertical speed, which remember, if you imagine this as a joystick, that's just pushing forward on the joystick to some extent. We'll say if it's greater than 0.1, okay? And we'll come back out of the blend tree and go back into an idle if our vertical movement is less than 0.1. So what we need to do now is we need to hook up a script that's going to allow us to fetch the current input axis from Unity's input class and feed them into these parameters. Now, the thing is, we need to be careful because we don't just want to feed in the parameters as they are, because that's only going to be in the -1 to +1 range. And if we go back to our blend tree, we can see that the vertical range is actually from sort of 0, or anything less than 0 will essentially be seen as 0, right up to 5.66, and the horizontal from about -2.32 to +2.32. So I think what we'll do is we'll scale the input axis that we get back from Unity by this amount, both horizontally and vertically. That's probably not the way I would do it in a game, but for now, for testing it, that's how I'm going to do it. So I'm going to select Geo, and I am going to turn off speed controller, and we're going to write a new script instead, and I'm just going to call this controller. So in my scripts folder, I'm going to create a new C# script. I'm going to call this controller, and I'm going to drag it onto Geo, and then I'm going to open that script up in MonoDevelop. So what I'm going to do is I'm going to grab Unity's input axes. So I'm going to say float x-axis equals input.getAxis horizontal. And if you haven't touched the default settings for Unity's input manager, then horizontal should give you either a controller or a joypad moving left or right, or your cursor keys and the A and D key as well. And for the y-axis, we just say input.getAxis vertical. Now these are going to give us values in the -1 to +1 range. So just to hard code this, I will multiply the horizontal axis by 2.32, which we just happen to know because we looked in the blend tree, is the maximum range that is supported by our animations. And the maximum vertical is 5.66 roughly. So we'll scale our input axes by those two values respectively. So I'm going to multiply vertical by 5.66. And then what I'm going to do is I'm going to declare a private variable of type animator. I'll call this animator, set it to null, and then what we'll do is we'll fetch that component and cache it in the start function. So I'll say animator equals get component animator, like so. And then in the update function, we can then just say animator set float horizontal and send in our x-axis value that we just calculated above. And then we'll say animator dot set float again, and this time we'll send in the second parameter, the y-axis, and that's called vertical in the animator controller, like so. Now there's something inefficient going on here by using the version of the set float function that takes a string as the first parameter, but I'll talk about that in a moment. But just in case you're a step ahead of me and you think, Gary, you amateur, you're doing this all very inefficiently, don't worry, I'm on the case. I'm just trying to keep things as simple as we can for now. Okay, so let's see what happens now if I press play, and hopefully this will work. There you go. Now at the moment we haven't got any turn on the spot animation, so once it goes back to idle, and let me click back up in the animator window, bring up the base layer so we can see what's happening. But yeah, the thing is, we're not really getting to see anything at the moment other than the running animations, because I think we need to sort of slow down the speed at which we ramp up to a full run. For example, the minute I press the forward key, it goes from sort of 0 to 5.66 almost instantly, and the same with the turns as well. So there is another flavor of the function to set the float or to set any parameter that takes some additional parameters called a damp time. So I'm going to set the damp time to, let me just say 1.0 for now, and I will send in as the fourth parameter, which you need to do, time.delta time. It needs to know how much time has elapsed for this frame so that it can apply the damping value. So let me just put in time.delta time again on this one. Now, the bigger this damping value is, this third parameter, the longer the animator is going to take to actually set the current value of the parameter to the value that you pass in as the second parameter. So it's a little bit like a quick and easy way of doing a timed interpolation from whatever the parameter is currently set to the value that we've passed in, so it doesn't happen instantly. And what you'll see when we do this is it should sort of slowly build up into a run. And if you look at the vertical parameter in the animator window, you'll see what I mean. See, it sort of ramps up much more slowly to that 5.6 value, and the same way it slows down more slowly as well. In fact, it takes forever to actually come to a stop, but that doesn't matter. So yeah, the horizontal movement is taking a little too long to update. So I like the fact that the vertical movement takes a long time to speed up and slow down, but the horizontal movement, which moves us left and right, has to be more instant. And we do that by lessening the value. So let's try 0.1 and see how that looks. I'm controlling this with the cursor keys, guys, all right? So there you go, starts to run. Yeah, there you go, that's kind of pretty cool. Now, don't get me wrong, I wouldn't be happy if this was the controller for my game, but as this demonstration, it does the job. It allows us to see that a single blend tree is being used to choose all of those animations. So you've seen another version as well there of the set float function, and in fact any of the set functions that set parameters, so set bool, set int, and set trigger, all have this different version of the function where we pass in time.delta time and we pass in a damping value, which basically increases or decreases the speed at which the value already for that parameter in the animator controller becomes the value that we've passed in. And this has to be called every single frame, because each time we call it, it's using this damping time to just move what the current value of the parameter is just fractionally more towards the value that we send in. So the problem with our code at the moment is that we're using the set float version of the animator function that takes as its first parameter a string to describe the parameter that we want to set. Now this is inefficient because inside the system internally those states and parameters are not represented as strings, they're represented with hashes, which are like integer values. So every time we pass in a string such as horizontal or vertical, a calculation has to happen on this string to generate the integer hash from it. Now this can be quite time consuming, especially as in a game you might have thousands of characters all calling one of these set floats, set integer, set boolean functions multiple times per frame. So the general practice is that if you're going to call something a lot every frame, then you wish to pre-calculate the hash so that you can use a version of the set float function that takes an integer ID instead of the string. And that's pretty easy to do, but we're going to need a few more private members. So I'm going to create a private integer and I'm going to call this horizontal hash. Set this to 0, and I'm going to create another private int and I'm going to call this vertical hash. And then in my start function, I'm going to use a static function of the animator class called string to hash. Dun, dun, dun. Knew there'd be a function to the rescue. And we just pass in the name of the parameter that we wish to fetch the integer hash for. So I'm going to pass in horizontal. And of course, I want to store the returned integer in my horizontal hash member. Actually, I've just noticed that I've used a capital letter on the first word of those hash private variables. That is against my rules. So I'm going to store the returned integer from that function in my horizontal hash, like so. So I've now stored that integer. And then I'm going to do the same for the vertical hash as well by calling the animators. Remember, this is a static function, so we don't get to it using the instance of the animator, but by using the animator namespace itself, string to hash, vertical. And then what I can do is I can delete those strings from the set float function and instead just send in the pre-cached integer, horizontal hash and vertical hash, like so. Now that's going to be much more efficient, and like I said, especially when you're actually working on a real game with a real game scale, you're going to have lots of these function calls all over your scripts, multiple ones from different components, all kind of calling this function, and then those conversions from a string to a hash each frame can really start to add up and affect performance. So always pre-calculate the hash and then use the hash version of the function to set the value of the parameters. Let's save that off, just check it works. Shouldn't look any different, but I just want to check I haven't broken it since I applied the hashes instead of the strings. And let's see, a slightly come to a stop and go into idle. Yep. Okay, so finally, to just have a bit of fun and to cement what we've learned about talking to the animator controller via scripts, is I'm going to do it so that when we press the fire button, we go into an attack and we see Jill lash out with her arms. Now, currently this is a Boolean, and that suited me fine for just demonstrating it to you using the parameters panel. But in our game, when we press the fire button, we don't want the attack to stay set like a Boolean would. So if we press the fire button, she'll go into an attack animation and she'll just stay there forever unless we can toggle that off somehow. So this is ideally what a trigger would be used for instead of a Boolean. So what I'm going to do is I'm going to delete this parameter, because unfortunately you currently can't change the type of a parameter, which is kind of annoying, because when I delete this parameter and then create a new parameter with exactly the same name with a different type, I think that's going to have buggered up my transitions in the attack layer, so I'll have to reset them again. So I'm going to delete this parameter. If you're watching this and you're thinking, Gary, you fool, there is a way to change the type, you just don't know it, then hey, hands up, I don't know it, please let me know. So there you go, I'm going to call this trigger attack, like so. There you go, and I'm just going to check these transitions because they're probably oh, luckily it's actually retained it. You'll notice when you look in the transition from the empty state into the attack animation, there is no true or false selection. It is just a trigger, so it's either set. So we're basically saying when attack is set, go into this animation. Now currently we had a transition back from the attack into the empty state that was to be set when that attack Boolean was set to false. There's no way to set an attack trigger to false. It automatically sets itself to false, so we just want to delete that and just let the attack animation, when it ends, transition back into the empty state. I think that should work. Just to reiterate, in case I was mumbling to myself there, the way this works is when that attack trigger is set, okay, this is picked up in the conditions of this transition that says attack is set. And like I said, there's no options for attack. It's an on-off thing. The way that triggers work is as soon as the animator detects that the attack trigger is set, it will cause this transition to be fired and will automatically reset the trigger off again. So we don't have to worry doing that in code, which is something we would have to do with a Boolean. The animation will then play for its full duration, and then once it reaches the end of its timeline, we'll go back into the empty state and carry on what we were doing before on the base layer. So all we need to do now is we need to set the value of this trigger to on when the fire button is pressed. So let's go back to our script, and the first thing we're going to need is another integer to use to store the hash of the trigger parameter, which is attack. It's called attack, isn't it? So I'm going to call this attack hash. Then in the start function we're going to say attack hash equals animator string to hash, and that parameter was called attack. So I think I'm going to use the left mouse button for this purpose. So I'm going to use Unity's input class to get the state of the left mouse button by saying if input.get mouse button down, I pass in 0 as the index of the mouse button, which is the first mouse button, the left mouse button. So if that returns true, the left mouse button has been clicked. So we say animator set trigger this time, the set trigger function. And this takes a single parameter because we have no values to assign to a trigger. We just set it on, and then as soon as the animator detects the trigger's been set, it will fire the transition, and then it will reset the trigger back to off again. So I just have to pass in attack hash as that parameter. So let's save that off and see if it works. Okay, here goes, folks. Fingers crossed. So I'm going to start in the idle position. Let me click the left mouse button now. Wash. Oh yeah. Let's check she can walk and swipe, and she can turn and swipe, and she can turn left and swipe, and she can run and swipe. Yes, she can. How good is that? Down, 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 down. Bow wow. Sorry about the music there. That is actually the Dead Earth theme tune, but to be fair, I didn't do it a lot of justice there, but if you haven't heard it, go and check it out on the Dead Earth promo video. Very proud of it. Composed it myself in one afternoon using Cubase and some nice VST plugins. So I think that's pretty much it for this lesson. We've learned quite a lot, haven't we? We've learned how to build an animation state machine. We've learned how to assign that animation controller to our animator component. We've learned how to create avatar masks, how to use multiple layers, and we've also learned how an animation state needn't just be a single animation clip, but could be a blend tree, either one-dimensional or two-dimensional. And of course, we've also seen how we can set the values of the parameters via our code, which is something we're going to be doing a lot. And also, we're going to see in later lessons how there's times when we wish to read the values of the parameters back, because you're going to see later when we discover animation curves, which are essentially a way of adding a curve to an animation clip on import. That animation clip can actually drive the value of parameters. So for example, we could have a situation where a guy swings a sword and we set an animation curve on that clip so that it sets a parameter to true when the sword is in the kind of the deadly position, and then that animation will drive that parameter, and then our code will be checking for that parameter, and when it's set to true we'll know to apply the damage. So in this case it's actually the animation clip itself which is telling the code what to do and when things should happen, and that's all pretty exciting stuff. But in the next lesson we're going to see how to take an animation state machine and how to get it to play nicely with a NavMesh agent component, because that's what we're going to want to do with our zombies, because at the moment they would both be fighting for supremacy, because both systems want to update the transform of the game object with completely different ideas of where our character should be going. So that's going to be a lot of fun. No, it's not. It's one of my least favourite subjects, if I'm honest, but you might be looking forward to it. And if you are, that's good. So thanks for listening to me. This has gone on a bit long, this lesson, and in case you haven't noticed, I've gone, I think in the last 20 minutes, just a little bit crazy. But I will see you next time around, folks. So if you don't give up already, I'll see you then. Bye-bye.